Greetings everyone, I am Mikhail Sokolov. I am 17 years old and I am a senior at the Northeast Federal University Lyceum in Yakutsk, Russia, and a member of Sakha Junior Science Academy. Today, polymer composite materials are widely used. Their adhesive quality is essential for the high-strength polymer composite materials. Therefore, the improvement of fiber-polymer adhesion interaction is the most critical task at hand. In this study, I have developed a method to increase the interfacial interaction between ultra-high molecular weight polyethylene and natural basalt fiber. In this slide, you can see various components of the polymer composite material. I have used as a polymer matrix the Celanese GUR 4130 grade ultra-high molecular weight polyethylene with an average molecular mass of 6.8 raised to the power of 6 gram per mole, with a bulk density of 9.4 gram per milliliter and a mean particle diameter of 150 to 200 micrometers. To reinforce the polymer matrix, I have used as a filler locally produced natural basalt fiber. To increase the combined strengths of the polymer matrix and fibers, the mechanically and chemically modified basalt fibers were used. In the slide you can see the samples which were prepared using the hot compression molding method at 175 centigrade under the pressure on 10 megapascals, which were followed by a cooling procedure. The following properties of polymer composite materials were tested, such as physical and mechanical, elongation, tensile strength, and modulus of elasticity, as well as tribotechnical, coefficient of friction, and mass wear rate. And in this slide, the mechanical properties of the samples are shown. It is established that composite materials made using mechanically modified natural basalt fibers have higher mechanical properties. To understand these effects, the morphology of composite materials samples was studied using a scanning electron microscopy. In this figure, one can see that the composite materials containing mechanically modified natural basalt fibers show the substantial fiber grinding. These short fibers exhibit all the characteristics of a dispersed filler during the crystallization, being a center of crystallization. Therefore, these short fibers contribute to the formation of spherulites with small structure elements. The following slide shows the tension sample fracture surface. As you can see here, the composite materials with the coupling agent and a surfactant improve interfacial interaction and facilitate the bonding on the filler surface with a polymer matrix. Next slide shows the composite materials containing modified natural basalt fibers with the Celan have very high wear resistance. This may be due to the fact that these fibers have a smaller contact area between an ultra-high molecular weight polyethylene with a surface of steel counterface. The orientational effects may also play a significant role. So, by adding fibers to an ultra-high molecular weight polyethylene, it is possible to decrease the wear rate to the composite materials. The figure 9 is the composite materials wear surface morphology. It shows that the adhesion is the one predominant wear mechanism during sliding, when these grooves are oriented along the slip direction. These grooves were formed as a result to the plastic displacement of the material by the solid particles of the steel counterface. Morphology of the unmodified fiber composite materials friction surface shows that the polymer matrix is weakly bound to the fiber, and the fiber split out from the matrix during the friction. It leads to a rapid decrease in composite materials wear resistance. In the case of the composite materials with modified fibers, the wear debris were not observed. The friction occurs on a surface of the fibers localized along the friction path due to the improved adhesion interaction between components of the phase change material. The preliminary treatment of the natural basalt fibrous surface improves the wetting of the filled surface with a polymer matrix, which was confirmed by structural studies in this research. In conclusion, it can be confirmed that natural basalt fibers play a significant role as the reinforcement and improvement of the mechanical and tribological properties of a polymer in the present experiments, which is also confirmed by the table comparing the properties of polymer composite materials with different fillers on the slide. Finally, I would like to thank my supervisor, Mrs. Sahayana Danilova of the Northeastern Federal University, also my school, Dr. Vasily Pavlov, and the Saha Junior Science Academy for helping to carry out this research project. Thank you for very much for your attention.